So, in this program, we decided to test the most common means of protection for strength, unsinkability, and fire resistance. More correctly, fire and gas resistance. What did we get? Let's see. We are very sincerely concerned with the question, and what if? The same is here. What happens if a brick really falls on a protective helmet? Dropping! Well, it seems, after all, the helmet was stronger. And the helmet really was stronger. Honestly, I'm beginning to doubt the head of our dummy. It's not tightly fixed. We continued to test the helmet. What else can fall on the head at the construction site? Actually, everything. We don't waste time on trifles, and we'll throw something that's more interesting. A crowbar. Watch out, crowbar! Crowbar! Well, the helmet is knocked off the dummy, of course, and the poor head, I think it's already giving up. It's an eyesore, and although the helmet is quite resistant to blows, but the head is crumpled into an accordion, and something's telling me we need to approach our experiment differently. So, we begin to find out the strength characteristics of an ordinary construction helmet. We throw a brick on it, a crowbar, and then it seemed to us that something was going wrong. The head of the dummy is flattened, torn from the fastenings, so we made it stronger inside, screwed it better to the table, and continued. Wrench! This, of course, is not a serious danger to the helmet. Chisel! Well, the chisel did not do any serious damage. The only thing is that it tore off the helmet, but the helmet itself was intact and the head was not hurt either. We dumped all sorts of things. We used a high-speed camera to, yes, we even dropped an axe on the helmet. Now, we used a high-speed camera to record the result. But what, in fact, do we check? Educational briefing. Protective helmets are only 100 years old. They were mass-produced for builders at the beginning of the last century. The first helmets were metal, but they were discontinued because the metal was a good electricity conductor. Then helmets were made of fiberglass, and then they came to be produced with their modern material, plastic. By the way, very few people know different colors of helmets correspond to the professional position of the one who wears them. White is for executives, red is for the foreman and craftsmen, and orange or yellow are for employees of junior and maintenance staff. Look closely at the color of the helmet that you will wear next time. So what are we trying to check? Any helmet protects a person's head from two troubles: the skull from trauma and the spine from vertebral compression. Let's start with the first one, the skull and trauma. If a dull object is falling on the helmet, say a hammer, or a sharp object, for example, a machete. Yes, we know that nobody has a machete on a construction site, but nevertheless, the result should be the same. It does not break through. The helmet should not crack, fly apart, nothing like that. After all the drops, we got a small hole in the helmet, but none of our shells got to the head of the dummy. Any helmet has protective and shock-absorbing properties. Here is the shock-absorbing system of the helmet, these elastic bands. And let's see what happens if I remove this system, put it on the mannequin, and something heavy will fall on top of the helmet. A brick. The ribbons in professional language are called the headband. And now, see the difference. Even visually, you can see how hard the helmet turns as if into a watermelon without the shock-absorbing system. Yes, we understand that even the super headband is unlikely to save a human neck from this. Helmet versus a cinder block. 1, 2, 3. But no one even said that a helmet is an absolute protection. It performs its functions, but up to a certain limit.
A protective helmet is necessary in order to protect the worker from being hit by, for example, a building structure. It may be a kind of building or some kind of production. Well, and from flying objects, as those you already threw.
Yeah?
Bricks, screwdrivers, and so on.
So, the verdict of our program. Modern helmets are a protection against penetrating wounds and from injury to the neck and spine. Even more so, they easily withstand the impact of a very heavy object. They do not break and they don't break through. But a helmet cannot give a 100% guarantee of protection against vertebral compression. You're still in doubt whether you need to wear helmets where necessary. I hope this video dispels your doubts. How to survive in a fire. We'll try to hold out in those conditions where a person dies within a couple of minutes. And do life jackets really save lives? It's another experiment of our program. The flame isn't the most dangerous thing for a person in a fire. It's necessary to be afraid of smoke and carbon monoxide. That's why I decided to try a device called a self-rescuer myself to understand how effective it is.
A self-rescuer allows you to breathe. If a person has the ability to breathe, then they can leave the danger zone. That's why, actually, a self-rescuer is needed.
Do I need to know anything as a person who's going to get through this experiment? Prepare somehow. Practice.
Actually, self-rescuers, including those that we will now test, allow a not very prepared person to use them.
Well, the greenhouse is filled with smoke. so you cannot see anything inside. Whether there is some oxygen for breathing, I have no idea. But since the creators of the self-rescuer are sure, everything will be all right. Good. Well then, I've honestly never put it on before.
Okay, you'll try it this time.
You need to put your hands this way.
Yes, in your head. There.
Check it.
Pull it down there.
To the end?
Here, to the end.
Yeah,
And make sure that it's on the place, well, a bit lower, like this,
yeah,
so that the mask is on the place.
that's right.
Well, go on then.
Well, okay, I'm going in. Well, of course, the visibility here is almost zero. I can move literally by feeling. But one thing I can say for sure, you feel comfortable in the self-rescuer. That is, I don't feel any smoke inside. I can breathe. So, somewhere at the end of the greenhouse on the other side, there was, well, a chair was put so that I won't have to stand all the time. So I get the chair and sit down. That's it. I have to stay in this monstrous atmosphere for more than 10 minutes. What a contrast. Fire and water. Leave me in a greenhouse filled with hot and pungent smoke to test another self-rescuer. It's called, well, of course, the life jacket. In such cases, they say, you need to start with yourself. We are in the test pool of the Aviation Center. We have several types of life jackets here, and this is our plan of action. Everything is very simple. I have to put on different designs of life jackets and jump with them into the water. There are two main tasks. The first is to see how well the life jacket keeps me on the surface. And the second, in case of complete immobilization, if I won't turn with my face down. No sooner said than done. Let's proceed. Well, this lifeline is lightweight. It is for small boats, water sports. It sufficiently preserves the mobility of actions. We'll verify it. Well, everything seems fine. Now I don't move my hands or feet. The jacket is holding me confidently on the surface. Yes, it has inguinal belts, so when you jump into the water, the jacket remains on the person. It doesn't fall off. After this immersion, a jump. That's all right. Let's start the second experiment. So, now I'll try it in different poses. Completely relax and see if this jacket keeps me on my back or it's possible to turn over completely to my chest. So, now on the back, here I am completely immobilized. And now I'll try to lie on my chest. Well, actually, it seems to me it's not a good idea to be in such a jacket when being unconscious. And it turned out to be true with many life jackets made. Sorry for repeating with the design of a jacket. They keep a person well on the surface of water, but a person must control their position. And if a person loses consciousness when falling into the water, then he or she can turn on their stomach. And then the person will choke. no doubt. But it turns out there is a unique design of a life jacket in which you won't stay in this position. It's a river life jacket. It's used to equip river passengers and transport ships. And it looks a little different. We'll test it. In the design of this waistcoat, the entire filler is located on the chest. So whatever a person does, he or she will always be turned on the back. Guaranteed, and I personally checked it. Because of its design, you are turned over. So here, you shouldn't be afraid that you'll be unconscious. The vest will do its job, and you will confidently keep your face up. By the way, according to a similar scheme, the life jackets are made for passenger aircraft. The same principle works for airbags on the chest. So even in the unconscious state, a person will never have their face in the water. Well, it's time to return to the tests of the self-rescuer in the greenhouse filled with smoke and carbon monoxide and find out, well, how am I in there? It's weird. I thought there would still be some kind of penetration inside the self-rescuer, at least some particles of smoke. Here, I don't feel anything. I breathe normally. Well, at a distance of an outstretched hand, I can still distinguish something, but not anymore. All the rest, of course, is in smoke. This is a strange sensation. After all, I'm breathing through filters. That is, even in such a gassed atmosphere, there is enough oxygen for breathing. But at the same time, the concentration of toxic gases and smoke is so strong that it takes one breath when a lung seizure comes. That is, a person cannot stay for a few seconds without a self-rescuer, without its filters, in such a place. So, well, judging by my watch, I stayed here for 12 minutes. Actually, I do not experience any unpleasant sensations. The amount of smoke varied. Visibility was almost zero, but nothing penetrated into the device of the self-rescuer. I still breathe normally, and, well, my eyes don't hurt. We'll assume that the experiment is complete. I'm heading for the exit. So, here I am. We close it, and we shoot. Oh. Well, what can I say? It's hot inside, of course, so I feel that I got all sweaty while I was there. But there were absolutely no unpleasant sensations. No pain in the eyes, not even, well, I did not even feel the faintest smell of smoke.
Well, you can stay there.
How much?
In the hardest conditions, where we had the experiment, we could do it up to 30 minutes for sure.
It's enough for a person to come down from which floor?
Well, one floor takes a minute. If you do it faster, then it's the 40th floor and higher.
We live in a safe world. No, our world is full of dangers, which a modern person, as a rule, is not ready for. Threats are fire, water, and even a notorious brick on the head. By the way, in the world, every year, several people die from a building brick that fell from above.